artist-scientist presenter today is Dr. Randy Fruzzo, who earned a doctorate in geology from the University of Washington and, unsatisfied with the constraints of sciences, then pursued a PhD in theory and composition from the University of California, Davis. Passionate about new music and old rocks, this scholar performs regularly and teaches students about the composition of both geological strata and musical forms, which are profoundly interrelated in terms of creative processes and human experiences. Fruzzo is devoted to understanding one of the oldest stories on our planet, which includes the symphony of the early Archean period of Earth's formation and the crescendo known as the Teton Range. Fruzzo's work has been presented around the world at various geomusical festivals, in Brazil and Italy, where he moved audiences by playing the clarinet as a means of better understanding the geological forces shaping the Earth's crust. Fruzzo's recent publications include The Legend of the Wyoming Province as recorded by granitic magmatism and played into the rocks of the Wind River Range by flute, oboe, clarinet, and bassoon, which was published in the Journal of Precambrian Wind Ensembles. And the use of piano accompaniment in the silent movie of Seafloor Formation, a geo-auditory exploration of the metamorphosis of rocks into music, which was published in the Journal of Earth Sounds. Guzzo is perhaps best known for her groundbreaking book on the history of rock music, which was titled, Why We Should Take Music for Granted. And once again, I encourage you to visit the University of Wyoming's websites for the departments of music and geology and geophysics. There you will find the absolutely illustrious accomplishments of Dr. Andy Guzzo and Ron Frost, whose rather phenomenal careers I mashed together into something of the sort that might actually happen if universities were in deep conversation and authentic collaboration between the arts and sciences. But until then, I'm delighted to turn the program over to these two wonderful colleagues who have taken the first bold steps of wondering what it would be like not only to express, but to come to know the geological world through the medium of music.
Amazing introduction.
So I'm the geologist, not the music person. And geology, as you probably know, is a historical science. Now, that's to make a contrast to experimental science. You know, so chemistry, you can do experiments in the lab, and physics, you can do experiments in the lab. But if someone came to me and said, well, how did the bighorns form? I can't go to a lab and make the bighorns. It just wouldn't work. So in geology, you go and observe what's going on in the field, you look at the rocks, you use a lot of accumulated knowledge that you've seen from a lot of rocks, and you try to make inferences. And then when you get inferences, you essentially tell stories. Who are we telling the stories to? Each other, okay? And we tell stories with lots of mathematics and lots of chemistry and really long polysyllabic words. And you know, it turns out these things are pretty dramatic stuff. So on the days when we were supposed to pair together and walk around, Annie was suggesting, well, maybe we can make an opera on the Powder River Basin. I said, oh, that's a fabulous idea, because geology is a story. What better, more dramatic way to tell a story with opera? And she said, good, you write the libretto and I'll write the music. What the hell's a libretto? So, the first task was to put something together which was sort of poetic like Naomi's, but I'm really afraid that she's a lot better a poet than I am. So, geological writing and scientific writing in general is, I tell my students, you make believe you're a lawyer in a very important case, and you're going to present your case on the film, and you put together the data, you build the data together, and you try to lead the reader to a conclusion that cannot be missed. So the writing is almost invariably, what should I say? Well, not quite convolute, but there's lots of dependent clauses in which you stick this together and this together and this together and finally come to this conclusion. And that is not the kind of stuff you could put into a libretto. I mean, it doesn't work that way. So the first thing I had to do was simplify, simplify, simplify. There's one famous person once said. Before I read it, I have to give you some information because I don't want you to think that the Rocky Mountains went up just a couple of thousand years ago. So the Rocky Mountains have two stages in formation. The first one, which happened way back about, it was a long process between 70 and 50 million years ago. The mountains just smashed together. The big thrust faults that we see that bring up the bighorns and big up the wind rivers formed there in this thing we call the Laramide orogeny, which was not named after Laramie. It was named after Fort Laramie because at the time this thing had been discovered by the Hayden expedition, that was the major town in Wyoming. And then, for a long time, the mountain just sat there and he eroded away and he eroded away and he eroded away. And essentially the basins filled up almost to the tops of the mountains with, it's not dirt, sediments. And then, an interesting thing happened, that something made the mountains go back up again. Or something made the basins get eroded away. The first person to recognize that the mountains had two stages of evolution was a guy by the name of Wesley Powell. As he went down the Green River and came to the Canyon of Lador, he saw the sediments going up and the sediments going down, and the river went straight through the middle. And it didn't make any sense that the river would cut straight through the middle unless the river's bed was there before it encountered those folded sediments. So it's called an epiorogeny. So that's in the first line. There's some other fine terms in here that I won't explain until the end, but here it is, and I apologize if it's not poetic enough for you. Fortunately, when it gets to be an opera, all this good music will cover it up. Then 6, 8, or 10 million years ago, the epiorogeny began. Slowly, slowly, from New Mexico to Montana, the mountains rise. 2, 4, 6 feet, 1,000 feet or more, the mountains rise, and the basins go up with them. The rising of the basins rejuvenates the Powder River. Once it was a sluggish old man river that meandered lazily across this muddy floodplain. Now the river is active and begins to excavate the sediment it had laboriously laid down. The sand grains, which had begun their lives as rocks high up in the Bighorn Mountains, begin to move again. The Powder River picks them up and carries them down to the Yellowstone, to the Missouri, and finally to the Mississippi, where they become building blocks for a growing delta. Erosion chews deeper into the basin and it exposes coal beds to the air. The combination of oxygen with the volatile, rich subbituminous coal leads to something new. Subterranean conflagration. The Powder River Basin is a land of fire. In late summer, the restless, relentless sun desiccates the grasses. Large thunderstorms roll by, but cruelly keep the rain to themselves. The lightning-caused fires rage across the countryside. When the fires meet the coal, anxious to rid itself of its metastable hydrocarbons, readily joins the conflagration.
So sexy.
The fire creeps along the coal bed, it smolders slowly in the seam and leaves the overlying rock unsupported. Gravity finally wins, the rock above the coal seam fails, fractures race to the surface. Oxygen streams in, hits gases from the coal and flames roar like a blast furnace. Temperatures soar, generating pyrometamorphic anatexis of the surrounding peatlands. Fragments of the roof fall into the paralava, producing a vesiculated lithic paleomictic breccia known as clinker. Coal seam fires burn for thousands of years. The fire smolders here, flaring there, gnaws its way into the earth. When the fire goes out, it is with either a bang or a whimper. It may encounter the water table and is snuffed by a massive steam explosion. The roof of the seam may refuse to fall, deny the oxygen it needs. The fire slowly starves. The fire leaves a surface full of sinkholes and fissures. Erosion strips away the soft shale. The indurated clinker soon caps the topography. The clinker cap shrinks as erosion nibbles away at its margins. After a few million years, all that's left are isolated red-topped hills and red pebbles in the Powder River. Looping across the high prairie, the Powder River murmurs its way from highlands of the Bighorn Mountains to the valley of the Yellowstone. Meandering past soft hills graced with grazing cattle, it is the iconic river of eastern Wyoming. So that last one is the sort of the theme. This is going to be the geologic history of the whole Powder River. So we'll put that last theme on the very front. Then we'll talk about the laramide and rogine and all that cool stuff going on there. And then we'll talk about the sediments, and then we'll go to the clinker.
So I want to second what you said about these people being amazing teachers, because when Ron gave us his lens, the first day we all gave our lens on how we saw, heard, experienced the landscape, and he was so animated. You see him sort of almost conducting with his hands as he talks about this stuff. And when we went on the hills, he was a mountain goat with his Swiss hammer up on the top of the Clinker hills. And he was explaining all this stuff, and it was so dramatic the way he explained it. But then as we went on the talk and I learned about the landscape, which I loved, I couldn't help but filter through my lens, which is a common theme. And my lens hears narrative as opera, right? Or composition, but opera is a very literal kind of a musical form. And I couldn't help but think about moldering, this moldering coal seam underground. Isn't that every baritone, every evil baritone you've ever known in an opera? That's Iago and Verdi and the Count in the Marriage of Figaro. They're just scheming horrible characters, right? So this crash and attack of lightning, or whatever we're going to end up using to start the fire, and the moldering for years, it was the scheming baritone. And for me, the water sources, so the fire is the baritone, and the water sources are going to be my soprano. The calming effect, the long-suffering and yet powerful, because that coal seam's burning for thousands of years. But the flip from traditional opera, usually the baritone strangles the soprano, right? Or something like that. Now in this case, the soprano, the Powder River, wins out. So we're flipping the narrative. So in addition to that sort of inspiration that Ron gave with his animated storytelling and teaching, as I learned more about the geologic processes, I could make musical components out of them. So what I'm going to do is I'm going to show you guys, as Ashley spoke about in hers, sketches. We'll get that back together. Sketches of the opera and the two sort of climactic moments. So moment number one is this beautiful singing aria that is the Powder River. And what I did with this, as far as taking geological information, was twofold. First, I took the idea of the epirogyny. Saying that right?
Epirogyny.
Yeah, it's a sexy opera word, isn't it? Oh, epirogyny and conflagrations. That happens in every opera, right? So I took that idea of this high basin that was slowly, all that material in there, going away to the Mississippi and that area. And so that slow taking away and the motion of the river up and then down faster as it gets across the bighorns. And so the soprano, this is the soprano aria, and what I have for you is a beepy computer version, so I'm going to apologize. I tried to get them to be more musical, but they wouldn't listen. So the first aria will show this arch of a melody that hits a high A flat at the top, representing the top of the bighorns, and then this removal of material until we're back to the simplicity of the meandering river. And it's that last paragraph that he said. You'll see it on the screen. So we start out with just some wordless oohs and ahs. I don't know how many of you read music, but here's the mountains going up further and further. And then we finally reach this crescendo up here at the top of the mountains. And then as it descends down to the valley of the Yellowstone, it takes away all that material and goes back to the simplicity of the beginning. So here's our long-suffering soprano, which is represented by an oboe because the soprano sound is very grating. Thank you all. I hope you can see my love of Wyoming in that. I'm a native from Laramie, but you know, these spaces in the geology really mean something to me. Okay, so for the next one, this one's not complete. There's only so much of an opera you can write in 2 days. Okay, Jeff. This one though will give you a sample of some of the conflicted music and some of the anger and angst and moldering that's going on in the fire-struck coal stream. I want to demonstrate. So when Ron was out there hiking, he's on top of a hill of clinker, and he starts to slide down the clinker scree. And clinker sounds like that, okay? Its name is
Onomatopoeia.
Yeah, because here's the sound. So this is going to be an instrument in the percussion section in the final opera score, the bucket o' glass. It's a technical term. He's practiced for days to be able to do that. But what I'm going to do, because it's a little dangerous for us to have, broken piles of glass, and we really want this bucket full, I'm just going to tell you where the clinker sounds are going to come in. I'm just going to go shh and stuff like that in my my score. But a couple of the techniques with the stirring that you just heard, but also a sort of an accompaniment that keeps the glass going as long. We'll get a better scoop, but that sound. So when he slid down the mountain, that's what it sounded like. And so that inspired us to get this strange instrument. It's been done before, but here it's the perfect justification. Okay, so this is fractures for the baritone. And I want to point out a couple of things in this score. So I'm using some of the same techniques. I want to interrelate the opening, or that beautiful aria, with this ugly music. But when you're writing an opera, you want your characters to not only look different and be in different voice ranges, but have different styles of music. So the Powder River, the soprano, is beautiful and hopefully very tonal and moving. And the clinker, the burning coal, is atonal and jagged and rough and abrasive and cutting. So that's the idea here. And moldering for a while. So I put scheming as my expression word at the top. Also, the first line that I chose for this aria was the fractures. Fractures race to the surface. And then the next line is oxygen streams in. So what I did is for the fractures, I made these fractured lines. They're not straight, well-written, voice-leading lines. They're all over the place. And here is the fractures going to the surface as they scurry along like this, and they get higher and higher, and then finally with these clumpy, what we call cluster chords, where someone's just banging on the piano, it's come to that fracture. That's the breaking open. And then in these spaces, we're going to have the glass sounds. And then when the oxygen streams in, it literally streams backwards. We call it a retrograde in music. So every single note from this series came from the earlier series. And then the only difference is that I'm layering them so that more oxygen is coming in, building the tension that's about to become a blast furnace. And the climactic line is going to be...
Clinker.
No, not that one. That's important, but of this particular aria, pyrometamorphic.
And it takes us a piezoelectric rocks.
Yeah. So I'm going to be using that rhythm. It's a 6+4 kind of a rhythm to infuse the opera with the upcoming pyrometamorphic activity. All right, so let's listen to a little bit of the drama and angst and scheming of the baritone clinker. That's it. I'm going to have to leave you on edge. Now, Ron did me a magnificent service in finishing that libretto in just a couple of days so that I could actually have a couple of days to try to sketch out a couple of things. So, questions from our panelists, I guess. And if you want, you can play in the glass. Yeah, it is pretty fun. We should probably force you to have glasses on for this activity.
I feel like you guys bit off maybe the most of anyone with this project of thinking, oh, we've got 3 days, let's just write it out. But with a musician and a geologist, I mean, you had to do a rock opera.
Right,
Like,
right. It had to
couldn't
happen.
not
Exactly.
do
We
that.
couldn't. Yeah.
It was so operatic. The
process, right?
The
The process
like,
itself.
Information and then like taking the like sounds of geologic fieldwork and putting that into music. That's just. I'm a little at a loss for words. Just 'cause that's just so much fun.
Yeah, I kept thinking, Ron, as you were going through the words, how it must have been a really interesting exercise to kind of get the chance to explain why you have such a passion. You know, I mean, I think that you know, when you're maybe in teaching, but in writing papers and everything, you know, these are long processes and there's a lot of technical jargon and there's just so much drama, and it seems like such a perfect medium to be able to really kind of justify, you know, why there's passion there around it. And I also thought that it was really interesting. One of the things you said is that, you know, you in our disciplines we tell stories to each other. And I thought that was so wonderfully demonstrated within this whole day of, you know, how do we tell those stories outside of those silos, and I thought this was such an interesting way to do that, and expand beyond those boundaries.
Yeah, and I especially liked how the taking something that can be so burdensome in reading scientific literature and in like presenting scientific, which is the jargon and the, you know, pyrometric morphic yada yada yada, and there's such an amazing cadence to it that never comes out unless you do something like this verbally.
And can I tell you a funny story? The thing that was bothering me most were words like languid, because a soprano is going to have to put that L in their mouth. But pyrometamorphic and breccia, these are fantastic words. And opera's often in a foreign language, so why not this foreign language? And show its beauty, right?
Yeah. I'm just wondering about process, because obviously you had to have the words in order to kind of work from them. So how did you work together in that? You know,
Sure.
Because there could be kind of, you know, I'll do this and you'll do this, but how did that kind of cross?
Well, first of all, I had to understand the processes, so that was good, and a way for me to learn and have that curiosity sated in a wonderful way. But I think that you kept coming back to me with versions and variations, and at one point I had to say, okay, Ron, stop. I want only these words, and I will ask you which ones I want to change, because I'm feverishly writing.
We do have twice as much stuff on paper that will become, with a little bit of luck, the whole opera. You know, we do have a rough draft for the whole libretto together. It's just that, you know, every time I read over it, I said, oh, this verb is really boring. Let's put a really exciting verb in.
Right.
No, you don't put gnaws into a geologic paper. This river chews down into the rock. It just doesn't go in there.
Yeah, and also I think we agreed after reading it that we want a more active language. And so we just passed it back and forth about, does this word work better, does this word, how can we simplify that? Because as I was explaining to Ron, opera, you know, you can read a paper and what is that? How many minutes per page, you know, but then quadruple it for how long it takes to sing it. Because if I want to depict oxygen, I could just say fractures, oxygen, and be over with it. But that's no fun. And that's how I want to adopt the processes and put them in the music.
So you guys definitely see putting the finishing touches on this, bringing this
We
together.
have evil plans.
Fall 2015, we hope to be back here with the full opera.
All right.
To the National Geological Conference in Seattle and the University of Wyoming stage, or at least concert hall. So we'll see what happens.
This may go somewhere, actually. Questions, thoughts, observation?
I just think it's such a great pairing. You know, they're both about reverberation.
Yeah.
And music is so literal in
Time.
the way we experience, even though it seems abstract.
Mm-hmm.
And I'm not a geologist, but I've been reading John McPhee since I've been out here. I've been trying to understand, and some of it is so lyrical, but I can't get those events fixed. And this really helped me.
That's one of our goals, yeah.
Annie, I was interested in the rhythmic content of the second piece and wondering if your sense of pulse in that was very strong, was something that came from your sense of kind of what was happening in that whole stretch of time.
So if you look at the formation of the whole valley and the Rocky Mountains, I remember Rocks for Jocks, my one and only science class, when I was as a music major. I loved it, but it was a long time ago in a very basic class. And I remembered, okay, yeah, there was an uplift for the Rocky Mountains, but I didn't know there were two events that created this basin. And so when you really look at the picture of it, Clinker's pretty small in there, right? But it's sort
of the penultimate thing, because
Right.
you drive around the basin, particularly the northern part of the basin, at least for me, the Clinker always catches my eye. Just on top of the hill, there's this big red rock up there.
Yeah, I didn't tell you this, but in the the third measure from the end in the aria, there's some tension. And at the moment, that's a placeholder for the tension, but I'm going to take some of the Clinker material and put it in there to let everybody know it could happen again, because it does. I read a scientific paper that talked about current coal seam fires that are currently causing Clinker in China and around this basin.
So here we have a composer explaining to you a recent paper on the formation. Thank you. Every night we had a quote that set up the theme for the next day, and there was a quote on one day about risk taking, and I wish I had brought it with me. I'm going to have to sort of paraphrase. It came from Annie Dillard, right, who talked about fear, right? And she said, if we really thought about what we were doing, we would never start, right? And she says, what we need to do is jump off the cliff and make our wings on the way down. That feels like what happened. I thank you for coming, and I must say that you must have had a sense of adventure as well, given how little you knew about what was going to happen. So thank you for leaping off the cliff with us. I hope you enjoyed it. Enjoy lunch. Enjoy the rest of the day.
The Ucross Pollination experiment was sponsored by the Ucross Foundation, the Wyoming Humanities Council, Saturday University, the UW Biodiversity Institute, the UW Department of Philosophy, the UW Program in Creative Writing, and the UW Institute for Humanities Research.